In this video, we're going to work on continuing topic 8.3, and we're going to specifically look at properties of logarithms. So let's talk about these properties. So first of all, there's three of them. When we have something that we are multiplying together in a logarithm, and it doesn't matter if this is a log base A, if it's a common log, if it's a natural log, all of these properties work. So we would rewrite that as log. Since we had the base A, we're going to use the base A of u plus log base A of v. So multiplication turns into addition, okay? When we are dividing, log base A of u minus, so division turns into subtraction, log base A of v. Again, I've got a horizontal here, it turns into a horizontal. And then this is a power to a power. This is kind of a cool thing about logs. When I have a log of something to a power, I am allowed to bring that power in front. So log base A of u. So we literally can take it and bring it in front. It's a property of because logarithms act like exponents. So it's kind of a weird one, but you get used to it, and it helps us solve logarithms later on. So, and all of these properties work both ways. If I'm adding, I can switch it to multiplication. If I'm subtracting, I can switch it to division. If I have a number in front, I'm allowed to bring it up as an exponent. So we're going to start playing with these properties a little bit, and we're going to rewrite the expression of the natural log in terms of the natural log of 2 and 3. So basically, I'm only allowed to have these two things in my answer. So I'm going to start by figuring out what does 6 break into. So I know 6 breaks into 2 times 3. So another way I could rewrite that is the natural log of 2 times 3. I notice I have multiplication, and I just learned that multiplication turns into addition. So I could rewrite that as the natural log of 2 plus the natural log of 3. All right, looking at example 7. I know that 2 is already 2. 27, though, let's see, it breaks up into 3 times 9. And 9 is 3 times 3. If you want to go the factor tree route, or if you know that that's 3 cubed, great. So I could rewrite this as the natural log of 2 over 3 cubed. Then I notice I have division, so that turns into subtraction. So the natural log of 2 minus the natural log of 3 cubed. I have an exponent, and I'm not allowed to leave the exponent in there. It has to be just natural log of 2 and natural log of 3. So I'm going to go ahead and bring that in front. That's one of my new properties. So the natural log of 2 minus the natural log of 3. And then finally in this one, again, this is kind of a holdover of, hey, what if I don't get to use the calculator on this? They gave me the calculations, so I'm just going to replace those. But notice I have to be able to write the expression as a 2, a 3, or a 5. Okay, so I'm going to rewrite this to begin with as the natural log of base b of 3 squared over 2 squared. I notice I have division, so that turns into subtraction. So log base b of 3 squared minus log base b of 2 squared. And then I notice I have exponents because I can't replace this. We wouldn't be squaring these numbers. We can only multiply. So I can only replace if it's just log base b of 3. So I'm going to move those exponents in front. So 2 log base b of 3 minus 2 log base b of 2. And now I am allowed to replace these two things with what we were given here. So log base b of 3 is 0.5646 minus 2 log base b of 2 is 0.3526. And then we're going to use our calculator. We're going to multiply that all out. You could do it by hand if you really had to. We're going to use our calculator, and I got 0.424. And then finally here on example 9, we've got 50, which I'm going to break up into, let's see, I got to get it into 5s and 2s. So let's see, that's 5 times 10 and 5 times 2. So it looks like I can rewrite it as log of 5 squared times 2. And then multiplication turns into addition. So log of 5, log base b, I forgot my base. Base b of 5 squared plus log base b of 2. And then again, my exponent moves to the front. So 2 log base b of 5 plus log base b of 2. We've got to replace the log base b of 5, and it looks like we replace it with 0.8271. And then log base b of 2 is 0.3526. And again, I probably used my calculator, and I got the calculation 0.0068 was what we got, so that would round to 0.007.